Welcome to your podcast for Lesson 30, Net Force Problems Using Newton's Laws. After watching the podcast, you should be able to find all the forces acting on an object and exclude forces done by the object, and also draw all the forces acting on the object to find the net force. And so really, if you look at the objectives, it's really nothing new in terms of concepts. It's just taking what we've learned over the last couple lessons and putting them together to solve a problem. And so we're actually going to work through the warm-up in this podcast. We learned from Newton's third law that for every action there's an equal and opposite reaction. And in this problem, the action is the rocket pushing the gases out, creating that thrust. Okay. The reaction then is going to be the gas on the rocket. Okay. We know it's going to be equal in magnitude but opposite in direction. And so keep in mind when we're solving this problem, we only sum up the forces acting on the rocket, which is going to be the gas on the rocket and also the FW, okay, or the weight caused by the pull of gravity. We're going to, in essence, completely ignore the force done by the rocket, okay, which is represented by the dashed line. So in the problem, it told us that the rocket is going to create a force of thrust, which is equal to 20,000 newtons. And that's only important because Newton's third law tells us the reaction is going to be equal to that. So I am going to call it Fg for the force of the gas on the rocket and set that equal to 20,000 newtons. The wording of the problem also told us that that causes an acceleration of this rocket in the upward direction at 2 meters per second squared. And overall, I know I'm solving for the mass of the rocket. Okay. Now remember we said you also have Fw, right, the force of weight that's acting on the rocket, and I know that Fw is equal to the object's mass times gravity. So Fw equals mg. Okay. Now taking Newton's laws and putting them all together. If I bring in Newton's second law, which tells me that F net is equal to mass times acceleration, I don't know the mass, I do know the acceleration, I don't know F net, but I can write a separate equation for F net so that I can substitute things in. My net force in this problem is causing the rocket to lift. And so what that tells me is that the force of the gas on the rocket has to be greater than the force of weight. And so that would leave us with F net is equal to Fg minus Fw. Okay. I'm going to substitute in now Ma for F net to give us Ma is equal to the force of the gas minus the rocket's weight. Since I don't know what the mass is, I'm now going to take my equation from down here, Fw equals mg, and I'm going to substitute mg in for Fw. So that now when you look at this equation, I don't know mass, and it's in two different spots in the equation, but I know the acceleration, I know the force of the gas, and I know my value for g is always a constant 10 meters per second squared. So to solve this, algebraically, what I need to do is get mass by itself. And so to do that, I'm going to add mg to each side, which will get it to cancel out over here. And it leaves us with Ma plus mg equals the force of the gas. Okay. I'm going to factor out the mass, and now I can get mass by itself by dividing by the quantity of A plus G. Okay. So when I plug in numbers now, it's going to be my 20,000 newtons, the force of that gas, divided by my acceleration of 2 meters per second squared plus g 10 meters per second squared. And when you plug this into your calculator, you'll get a long repeating decimal but you can round it to 1,666.7 kilograms. Now again, remember we're getting kilograms by substituting in kilogram times meter per second squared for newtons. The meter squared would cancel out and leaves us with kilograms on the top. And so our final answer is 1,666.7 kilograms.